Hey guys, it's Mr. Dugal, and today we're going to provide an introduction into three different forms, a couple of which you're already familiar with. You have exponent form of a number, which is written in our table to the left here. You have standard notation, which you might not know that it's called standard notation, but you're familiar with that as well. And then we have a new one, and it's called scientific notation, and we're going to get into that. So basically, up top we have our exponent form, which is 7 to the 4th power. Standard notation just means that written out. So it'd be 7 times 7 times 7 times 7. For 8 to the 3rd times 4 to the 6th, this would just be 8 times 8 times 8. There's 3 8s. And then 4 times 4 times 4 times 4 times 4, 4 6s. So that's how exponent form and standard notation works. Scientific notation works in a way that seems confusing at first because there's exponents involved, but actually when we break it down it makes total sense. We're going to do an example here first, 434 times 10,000. In order to figure this out, I'm just going to do 434 times 1 and then add the 4 zeros on the end because 10,000 has 4 zeros. So it'd be 434, 434 times 1, and then add 4 zeros, 2, 3, 4, and put our commas where they should go. The answer would be 4,340,000. So basically scientific notation works like this. It aims to get our non-base 10 number here over to a decimal. So in this case we have 10,000. That's going to be our base 10 number that we're going to be using. And then we have 434. It wants it so that it's in the ones place is the easiest way to say this. So basically in order to put a decimal so that the 4 is in the ones place, it's going to go right there. So it's going to go over 2. So I know that 4.34 times 100 is 434. And that's because I moved the decimal over 2 places. So it's 2 zeros here. Additionally, I have 4 zeros here. 1, 2, 3, 4. So in scientific notation, that number is written as 4.34 times 10 to the 4th, because I have 4 zeros there, plus 2 zeros here, so it'd be 10 to the 6th. There are 6 total zeros. In other words, 4.34 times 1 with 6 zeros afterwards. So 4.34 times a million equals 4,340,000. This is scientific notation. It's also possible that I'm going to end up moving my decimal to the right in scientific notation, and that I have a non-1. This is a little more difficult, but I think it's an example that we can get to. Let's first start by moving 655 to the ones place. It'd be 6.55. It'd be 6.55 times 10 to the second. Right now I have 2 zeros present. Those zeros are about to be offset because I'm moving my next number over to the right. And in order to do that, I'm going to move it over 1, 2, 3, 4. So in this case, it's 10 to the negative 4. Another thing to note is that I have a 2 instead of a 1 here. What this means is that I actually need to double my numbers here. So it'd be 13.1 times, I have now 10 to the negative 4th and 10 to the 2nd power. Again, I just changed this 2 to a 1 by doubling 6.55. So I doubled 6.55 to make it 13.1. And now I go to count my number of zeros. I have 10 to the 2nd is 2 zeros, and 10 to the negative 4, which is negative 4 zeros. The net of 10 to the 2nd and 10 to the negative 4th is 10 to the negative 2. Notice now that I actually need to simplify this one further because I doubled it. Instead of it being 13.1, I'm going to move my decimal 1 to the left. So I'm going to actually increase the 10 to the negative 2 to 10 to the negative 1. Remember, anytime you move the decimal to the left, so decimal left involves increasing the 10 power. So an example of that is here we had 434. I moved the decimal left twice, so I increased my 10 power to 10 to the second power. Anytime I move my decimal right, my 10 power decreases. An example of that here was obviously we had 2 10,000ths, and I decreased it by moving this number, by moving this number over 4 times, so it was 10 to the negative 4th. That's about it. Hopefully this is a help as an introduction to scientific notation. And also don't forget that we did put a term to what you've already been doing by defining standard notation in exponent form. Thanks so much for watching.